Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present Task 1 MTES3273 Issues in Teaching and Assessment for the Topics of Geometry. So, we would like to introduce our members. Me myself, I am Nur Ainun HASHIM.
Me, Nur IMAN Balqis binti OSMAN. My name is Nur ARYANIE AYUNI binti OTHMAN.
Okay, next one. Okay, this is issues in teaching and assessment of geometry. The first one including difficulty drawing three-dimensional shapes.
And the second one is difficulty in remembering names of geometric shapes. And last but not least, difficulty drawing 3D nets without concrete materials.
Enjoy. This is the KSSR Mathematics curriculum for year 2 for our topics under 7.0, which is space. Under this content standard including three-dimensional shapes, two-dimensional shapes and problem solving. But our group will cover the issues that occur to three-dimensional shapes, which is under the learning standard, pupils will be able to identify the three-dimensional shapes based on descriptions, identify basic shapes of three-dimensional shapes, and identify various nets of three-dimensional shapes. So under these three learning standard, there are a few issues that our group will discuss on the next slide.
Assalamualaikum warahmatullahi wabarakatuh. So, what is geometry? Geometry is an important part of primary mathematics because it helps people develop spatial awareness, logical thinking, and mathematical communication. Geometry learning is based on the co-curricular standard sekolah rendah, which emphasize conceptual understanding, mathematical reasoning, problem solving, and communication in mathematics. However, many people still face difficulties in learning basic geometry concepts.
Okay class, next teacher want you to draw a cube and cuboid in 3D shape. Okay, Aryani, take this paper and please draw cube and cuboid shapes in three-dimensional. In three-dimensional shapes. Teacher want you to label which one is cube and which one is cuboid.
This cuboid. Is it right, teacher?
Are you sure this is how the shape cube and cuboid looks in 3D dimensional in 3D shapes? Are you sure this is 3D shapes, Yani?
I'm not sure, teacher.
Actually, this is the wrong answer because this is 2D shapes. Teacher asked you to draw in three-dimensional shapes.
I can draw it because I don't see the shape. I need to see it in front of my eyes.
Okay. This replay shows that the difficulty in pupils to draw 3D shapes because they didn't see the concrete materials in front of them as an object that they wanted to draw. And they also doesn't know how to draw a dot line behind the in front drawing. So this is the situation that relate to the first issues. Okay, we go to the first issue based on the journal analysis of misconceptions on learning geometry for second grade primary school pupils 2022. Based on the tables, there are few students find it difficult to draw three-dimensional shapes, such as cube, cuboid, cylinder, or cone correctly and neatly. According to the data, this issue is uh, sec- the third or fourth highest issue that are related to second grade primary school pupils. So this is the first issue that we are going to talk on the next slide. According to the data, issue 1, which is difficulty drawing three-dimensional shapes, occurs because they are required to present depth and perspective in a flat two-dimensional surface, such as paper. When the students are giving paper to draw, as a paper is flat, they cannot imagine how the object extend backwards in space, which also requires strong spatial visualization skills. At the primary level, these skills are still developing, making it challenging for pupils to show height, width, and depth correctly in their drawing. So that's why this issue happens, because they have a limited spatial visualization skills. There are several reasons why pupils have difficulty drawing three-dimensional shapes. First, pupils do not observe real 3D models. They are usually not given opportunities to turn objects around, copy from physical shapes, or explore real objects. Because of this, they may struggle to transfer what they see into drawings. Second, pupils have weak spatial visualization skills. Three-dimensional shapes have length, width, and depth, but paper is flat. Therefore, pupils find it difficult to show depth in their drawings. For example, when drawing a cube, some pupils may draw only one square, making the shape look flat instead of solid shapes. In order to solve the problems, one of the suggested teaching solution is bringing real objects into the classroom. For example, teacher can use objects such as boxes to represent cubes or cuboid. Teachers also can bring cans to represent cylinders. Also, in mathematics class, there are also real 3D objects that teachers can use to help pupils when they do the drawing lesson, just like the pictures in this slide. Pupils should be given opportunities to hold the objects, turn them around, and observe different sides of the shape. This will help them to understand depth and solid structure before drawing the shapes. Why? This method is important because according to Jane Piaget learning theory, especially the concrete operational stage for children aged 7 to 11 years old, they learn better by touching and handling real objects rather than only listening to explanation or see the picture that be drawn by their teachers. When pupils actively explore objects by holding and rotating them, touching them, they can understand geometric concepts more effectively through real experience. This will help them to draw the 3D shapes correctly and neatly. In conclusions, hands-on learning helps people develop better spatial understanding and reduce difficulty in drawing 3D shapes. Moving on to assessment issues. Another assessment issue is that teachers often give the same assessment task to all pupils without considering their different ability levels. Some pupils may need guidance, examples, or real objects to help them understand the task.
to help them easy for them to draw. Meanwhile, stronger pupils may need more challenging tasks, such as drawing shapes from different perspectives. When assessment is not differentiated according to pupils' abilities, weaker pupils may feel discouraged because the task is too difficult for them. At the same time, stronger pupils may not feel challenged because the task is too easy for them. Therefore, as a teacher, assessment should be more flexible and consider pupils' different learning abilities to support better learning outcomes. So, as a teacher, we need to find a better solution, especially for weaker pupils. One of the suggested solution is using differentiated worksheets with tracing activities. Teachers can provide worksheets that ask pupils to trace dotted line first to form three-dimensional shapes such as cube. This helps them to remember the shapes. The instruction given to pupils can be simple. For example, trace the dotted lines to form the 3D shape. Tracing activities help pupils develop their fine motor skills because they need to control their pencil movement while following the dotted lines. This activity also improves hand-eye coordination as pupils learn to match what they see with how they move their hands. In addition, tracing worksheets help pupils become more familiar with the structure and form of 3D shapes. Through repeated practice, pupils can gradually improve their shape recognition and drawing ability. In conclusion, tracing worksheets are suitable for pupils with lower ability level because they provide guidance while still allowing practice. So, this will help them to recognize the pattern and help them at the same time to draw better three-dimensional shapes neatly and correctly without misconception, without misunderstanding about the shapes that have a different edge, vertex, and so on.
Based on table number 6, 73.3% of people reported that they find it difficult to remember the names of three-dimension shapes. This percentage is quite high and shows that most people struggle with geometric vocabulary. The problem is not only about recognizing shapes but also remembering and understanding their names. For example, people often confuse cube and cuboid, cylinder and coin. This shows that people tend to memorize shapes names without understanding their characteristics such as the number of face, vertex and the surface. So let's see what's the situation based on our role play. Okay, today teacher will teach you about three-dimensional shape. Okay, the first one is cylinder. The second is cube and cuboid. So Azwa, teacher wants you to follow what I say. So number one is cylinder.
Cylinder.
This is cube.
This is cube.
No Azwa, just say cube.
Oh, okay teacher, sorry.
It's okay.
Cube.
Okay, cube. This is cuboid.
Cuboid.
Okay, well done. Okay, class. So, Azwa, teacher want to ask you what we learned yesterday.
We learned about the name of three-dimensional shape.
Okay, so teacher want to ask you that what is this shape's name?
As I remember, it is cuboid.
No.
And that is cube.
No, Azwa.
Teacher, actually, I don't remember the name. I cannot remember the name because I saw the pattern is very similar.
I see. Based on our role play just now, the teacher showed pictures of a cube and asked the people to repeat, "This is a cube." When the teacher later shows a real box and asks, "What the shape is this?" Some people answered incorrectly or keep quiet. This shows that people can repeat their name during the lesson, but they cannot apply the knowledge in a different situation. For example, when asked about the number of fish or vertex, people were unable to answer because they only memorized the name without understanding about the characteristic. This clearly shows that memorizing without understanding leads to confusion and weak conceptual knowledge. In the classroom, teacher often shows shape of pictures, say the shape names, and ask people to repeat them. These methods focus more on memorizing rather than understanding. Pupils usually learn the name of the shape without learning their characteristics such as the number of face, vertex, and whether the shape has flat or curved surface. As a result, pupils may easily forget the shape names because they only memorize without truly understand the concept. Therefore, learning should focus more on understanding shape features rather than memorizing the names only. Okay, there are several reasons why pupils find it difficult to remember the names of three-dimensional shapes. First, the teaching approach is mostly teacher-centered. This lesson is usually explained by the teachers while pupils listen and repeat. Pupils are given very little chance to explore shapes using real objects. For example, when learning shapes, pupils only listen to the teachers and repeat the shape name without touching or observing real objects. Because of this, people become passive learner and only memorize the information. Okay, second, teachers often focus on teaching the shape names instead of explaining the characteristic of the shapes. People learn the name first, but they do not clearly understand the features such as the number of faces, vertex, or whether the shape has flat or curved surface. For example, pupils may remember the name cube, but they don't know that a cube has 6 flat faces and 8 vertex. Without understanding the characteristics, people may easily confuse different shapes. Third, there is a lack of concrete teaching material in some schools. Without real object or 3D models, pupils only learn from pictures in textbooks. This makes it harder for them to understand the difference between 2D and 3D shapes. For example, if people only see pictures, they may say the ball is a circle instead of spheres. In conclusion, teacher-centered teaching focus on memorization and lack of concrete material are the main reason why people have difficulty remembering and understanding 3D shapes. Based on the finding, 73.3% of people have difficulty remembering the names of 3D shapes. This shows that the current assessment methods do not help pupils understand geometry vocabulary deeply. Most classroom assessments focus only on matching shapes with their names or choosing the correct answer. These types of tests mainly measure memory rather than understanding of shape characteristics. As a result, pupils may remember the shape name during the test but forget them afterward because they only memorize it without truly understand the concept. They may also confuse shape such as cube and cuboid or cylinder and cone. In addition, assessment activities rarely involve real object, hands-on exploration, or real-life problem solving. This approach is not only fully aligned with the holistic and meaningful assessment emphasized by Kementerian Pendidikan Malaysia and the curriculum standard sekolah rendah. In conclusion, assessment should focus more on understanding and real-life application, not the memorization it's only. why this is happen? Most classroom assessment focus only on memory-based question. Teacher usually ask people to make shapes with their name or choose the correct answer. These types of question mainly measure memorization rather than true understanding. People may remember the shape names for the test, but they may not understand the characteristics such as the number of face, vertex, and or surface. There are several reasons why this happens. First, many classes has 30 to 40 people with a larger class size and limited time. It is difficult for teachers to carry out authentic assessment like hands-on activities or oral explanation. Written tests are easier and faster to manage. Number second, some schools do not have enough geometry teaching materials. Without real objects or 3D models, pupils only learn from pictures. This makes both learning and assessment less meaningful. In conclusion, assessment often focus on memorization because of time limits, large class size, and limited materials. However, this method doesn't fully help pupils understand geometry concept deeply. Correct? So, what is the suggest solution? The suggest solution is using the concrete pictorial abstract or CPA approach in teaching geometry. In the concrete stage, teacher can use real objects such as boxes, cans, or ball. People are allowed to touch, explore, and observe the shapes. In the pictorial stage, teacher can use diagram or pictures to help people connect real object with geometry shape. In the abstract stage, teachers introduce the correct mathematical terms after people understand the shape characteristic. This approach helps people understanding geometry concept first before memorizing the shape names. In conclusion, the CPA approach can help improve people's understanding and reduce misconceptions in geometry and learning. So, got it?
Class, I want you all to draw a cube map. Cube map. Okay, Azwa, can you try to draw the net of this cube?
Okay, I try, teacher. Yes. That here. Teacher, is this correct?
Are you done?
Wait. I think I left. I'm done, and I think this is the correct one.
Are you sure? A cube have 1, 2, 3, 4, 5?
1, 2, 3, 1, 2, 3, 4. Yes, 5.
So class, I think you can visualize a cube because I just give you a picture. I don't give you a concrete thing.
Yes.
So you can see how it folding, how it open, right?
Yes.
Okay.
I only see like that.
Now I will present the last issue, which is related to geometry also under KSSR. So based on a journal title analysis of misconception on learning geometry for second grade primary school pupils, the findings show that 83.3% of pupils struggle with drawing three-dimensional or 2D shaped net if they don't have a real object in front of them. This result confirms that identify the actual shape of the geometry based on the net is one of the problems in learning geometry. The main teaching issue is that many people struggle to accurately draw the nets of three-dimensional or 3D shape when they do not have physical models or concrete materials in front of them. This difficulty arises because understanding 3D objects on a 2D plane requires strong spatial visualization skills, which are still developing at the lower and middle secondary levels. Without real objects to touch, to rotate and unfold, people find it difficult to imagine that how the face of 3D shape and how to unfold them correctly into a flat net. The main teaching issue is that many people struggle to accurately draw the nets of three-dimensional or 3D shape when they do not have physical models or concrete materials in front of them. This difficulty arises because understanding 3D objects on a 2D plane requires strong spatial visualization skills, which are still developing at the lower and middle secondary levels. Without real objects to touch, to rotate and unfold, people find it difficult to imagine that how the face of 3D shape and how to unfold them correctly into a flat net. So, why this issue happens? First of all, because of lack of concrete models. People cannot physically handle shapes, so they struggle to see how faces connect. Without the experience of unfolding a 3D object, it's hard to understand the structure of the net. For example, when we ask to draw a cube net, people may just or draw square in line because they haven't seen or touched a real cube. For example, in Malaysia, many schools have large classes and limited resources. Not every people can have a set of cube, prism or other 3D shapes, making hands-on learning is difficult. Second, teaching to abstract. Even if the textbook show the net, lessons often do not help pupils connect the 2D net to the 3D shape. People may copy the net without understanding how the faces join together or how it folds. For example, a cube net is printed in the textbook. People may draw it as the same net, but if asked to fold it, they not mentally prepare, they will feel struggle, they might place the faces incorrectly or forget which face connect to which. And last, weak spatial reasoning. Some people find it hard to mentally rotate and unfold 3D shape into 2D nets. This skill takes time and practice to develop. For example, when drawing the net of triangular prism, pupils may misalign the triangular faces or place them in the wrong orientation relative to the rectangles. In Malaysia, with large classes, teachers have limited time to give individual guidance. So, pupils who struggle with spatial reasoning may fall behind. Next, the second issue is related to assessment, which is a paper-based test do not measure understanding. Many assessment in Malaysia classrooms rely on paper-based tasks that ask pupils to draw nets of 3D shapes. So these tasks often do not include physical models or visual aids. People are expected to imagine the 3D shapes mentally. As a result, pupils may just or copy a pattern without truly understanding how the faces connect. So, why this happens? First of all, it is because of limited hands-on assessment. Due to time constraint and large class size, teachers often rely on writing tests. It is difficult to assess each pupil using physical models during examination. Second, focus on final answer. Assessment usually check whether or whether the drawing looks correct. They rarely evaluate the reasoning process, so people may copy a memorized net pattern and still score marks. Third, misalignment with conceptual understanding. So KSSR emphasizes reasoning and conceptual understanding in mathematics. However, paper-based tasks sometimes only measure procedure skills. People may score well in drawing a cuboid net, but they still cannot mentally fold it or explain the phase connection. This means the assessment does not fully reflect real understanding. So, to overcome this issue, several improvements can be implemented. First, we can use physical models. Teacher can provide cubes, cuboid, and pyramid in small groups. People can fold and unfold this shape to observe how nets are formed. This hands-on experience and activity can strengthen spatial understanding. Second, use interactive digital tools. For example, applications like GeoGebra 3D allows pupils to rotate, unfold, and manipulate 3D shapes virtually. This helps bridge the gap between abstract and concrete learning. Third, encourage collaborative learning. Pupils can work in pair or in collaboration to predict where each phase should be placed before drawing the net. So they can explain their reasoning to improve conceptual understanding. Last, improve assessment methods. Teacher can include hands-on tasks such as giving a real cuboid or asking pupils to draw its nets. Oral question like how do you know this phase connects here can also assess deeper understanding. In conclusion, geometry is important in primary mathematics because it helps pupils develop spatial thinking and understanding of shapes. However, many people still face difficulties such as drawing 3D shapes, remembering shape names, and identifying 3D nets. This problem happens because teaching sometimes focus too much on memorization, and abstract explanation without enough concrete materials. Assessment also often focus on writing answers instead of true understanding. Therefore, teaching and assessment practice should include more hands-on activities, real objects, and meaningful tasks. This will help pupils develop stronger spatial visualization skills and achieve the goals outlined in KSSR.